Hello and welcome to this webinar entitled Getting Started with MapleSim. My name is Shola Slough and today I'll be walking you through an introduction to MapleSim to get you started building your first model. So we'll start with an introduction to MapleSim and then we'll get right into it and show you how to create your first model. From there we'll look at how you can create custom components and then how to extract and manipulate equations from system models. We'll also take a look at how to simulate and visualize your model. We'll finish with a summary and then look at some additional resources to help you on your way. So when you open up MapleSim, this is what you see. You're greeted with a welcome message that points you to some resources to help you get going. So you can click on any of those resources to find out a little bit more about MapleSim or how to get started building and visualizing, simulating your model. So here we have our 2D workspace in the middle. This is where we're going to drag and drop components to build our system models. On the left here, we have the different component libraries. So electrical library, 1D mechanical, multi-body hydraulics, and so on. So MapleSim includes over 550 components, which you can drag into the workspace and connect together to build complex multi-domain system models. So we're going to dive right in and start building our first model, which is a slider crank with an electric motor actuating the crank. So I'm going to go into the multi-body library and I'm going to drag a fixed frame into the workspace. Then I'm going to grab a rigid body and drop it here. So this will represent the mass and the center of gravity of the crank that we're building. So I'm going to right click on this and it gives me some context sensitive options here. So in this case I want to rotate this component and change its orientation. So I'm going to rotate it clockwise like that. So next I'm going to add two rigid body frames into the workspace. So these will define the offsets from the center of gravity to both ends of the link. Then I'm going to go down here into the joints and motion folder and I'm going to grab a revolute joint. So the first one I'm going to place here. So this will allow the crank to rotate around a fixed frame, and then I'll grab a second one which I'm going to place here, and this will give the connecting rod a degree of freedom. So I'm going to move these along a little bit and then just connect. So when I hover over a port here, it goes green and I can just click to the next one where it goes green. So now I'm going to grab the components here that represent the crank, and I'm going to group them to create a subsystem because I want two of them. So if I right click, again I get that context sensitive menu and I'm going to say create a subsystem. So I can just call it my link and say go ahead and do that. So when I double click and go into that subsystem, we can see those components that we just grabbed and put into the subsystem. So now I'm going to parameterize the mass and the length of the link. So I'm going to click on the rigid body and set the mass here to M. This link here, I'm going to set its length to L/2. And for the other one, I'll set that to minus L/2. Okay. So now, of course, we have to go and define what these parameters actually are. So I'll click here and bring up the parameter list for the subsystem. So here now I can define M to be a mass measured in kilograms, and I'll give it the default value of 1 kilogram for now. Then I need to define L as well. Here we're measuring a position in meters, and it can have the default of 1 meter for now. So now we can return to the workspace and go back to the top level. So since I want 2 of these, I can now right-click on the subsystem to copy it and paste. Now, when you create and duplicate subsystems in MapleSim, it can be a standalone or a shared subsystem. So in the case of the shared subsystem, when you duplicate it, the structure is maintained across each instance, whereas a standalone subsystem is unique in each instance. So in this example that we're creating, I'm going to create this as a shared subsystem. So I'm going to go ahead and click OK. So there is my connecting rod. For this one here, I'm going to say I want the mass to be 2, and I'm going to set the length to be 2 as well. So now I'm going to add another rigid body. So this will represent the center of mass and the center of gravity of the slider. So I'm going to rotate that. And I'm going to set its mass to be 4. Then I'm going to grab a prismatic joint. So this will constrain the movement along the x-axis. And also grab a revolute joint from here. So this will connect this second link to the slider. So I'm going to go ahead and connect. So now I'm going to add a probe to the prismatic joint. So I'm going to come up here and grab a probe and attach it here. And I can change the name here, and we can just say slider. And I'm going to measure the position. So I can call that position. Just connect this as well. So now we can simulate this and see what we have. So by clicking on this arrow here, MapleSim will run the simulation. And here I can just press play and see that motion. Okay, so let's go back to our 2D workspace. And now we can go and attach an electric motor to drive the crank. So I'm going to go into the electrical library up here. And grab this DC permanent magnet. And it needs a voltage source. So I'm going to grab a constant voltage here. And I'm going to set that to 4. And grab the ground as well. So let's just flip that. And then I'm going to connect that. connect this to the flange. I'm going to add another probe to the design. I'm going to put it right there so we can view the rotational speed of the DC motor. So this one I can rename, let's call it motor. And let's look at the speed. Okay, so now we can simulate again. And view the effect of the motor now driving the crank. So that's how we can quickly and easily create models in MapleSim. So just dragging and dropping components from the different libraries, simulating and visualizing the results. Now MapleSim comes with over 550 components that you can use in creating your design. However, there are some cases where you want to use or create a subsystem or Now MapleSim comes with over 550 components included. But it also enables you to create custom components to use in your system design. So in the next example that we'll look at, we will create a custom component. So whereas here we picked this DC motor from the electrical library to drive our slider crank, in the next example we're going to actuate a pendulum but use a custom component to specify the equations for a DC motor that we're going to build. So here we have the simple pendulum that we're going to use in this example. And now we're going to go ahead and create our custom component. So using this paperclip icon here, we're going to create an attachment, which in this case is a custom component. So our custom component, we're going to call it my DC motor. So we'll go ahead and create that attachment. So this will open up Maple, where we're going to go in and now define the algebraic expressions and differential equations for this custom component. So within these large square brackets, we'll go ahead and enter the equations that define the behavior we want. So in this case, we have the equations there for the DC motor already entered. So once the equations are entered, then the parameters and variables are displayed in the tables here. So anything defined by the user with respect to time becomes a variable, which we'll see here, and then all other values are the parameters, which are up here in this table. And then further down, Maple lets you create the graphical representation of what that component is going to look like. So here in this case, we have the positive pin and the negative pin of the motor. So you can move these around wherever you want them to be. And then you specify their properties. So in this case, this is an electrical port. It's the positive, and it's got a voltage and current associated with it. The same for the negative pin here, electrical port, it's negative. That's the name we're giving it. You can always change that and the signals associated with it. And then you can specify what you want to call it. So I'm going to call this my custom motor. And once you've done that, you can just ask Maple to create or generate that MapleSim component for you. So Maple will go ahead and create that custom component and then return you back to MapleSim. So here we see our custom motor that we've just created. And as with any other component, we can just now go in and drag it and drop it into the workspace and connect it up as with any other component. So in this case, I'm going to connect it to the rotational mechanical flange, to this joint here. So now that I've put it in my workspace, I'm going to connect the rotational mechanical flange to the joint. And then I'm going to power up the motor by connecting its electrical ports to a simple circuit to supply a constant voltage. So I'll go back to the libraries here, back into the electrical library. And then I want to grab a source. Here we go. And also ground. Okay, so I can go ahead and just connect this up. Close that up. In this case, I'm actually going to say that I want to control the voltage being applied to the motor so that it constrains the motion of the pendulum to within a specified angle. So I want to grab a constant from up here in the signal blocks. And I'm going to connect that to there and set that to 6. And then I can go ahead and add a probe so we can see what's going on. Let's add the probe here. Call that motor. And we can look at the angle and speed. So now we can go ahead and run the simulation and see what we have in the visualization window. So here we see the behavior of the pendulum being actuated by that custom DC motor component that we've just created. Okay. So here we can see the attachments associated with that custom components. We can see that Maple worksheet that we used to enter the equations and create the graphical view of the custom component and the component itself. So these are now associated with this MapleSim model here. So our custom component template can be accessed here from the Project tab. So we can see the attachments associated with this So the custom component template can be accessed in the Projects tab. So if we go to the Projects tab, look under Attachments, Custom Components, and there it is. And if you need to, you can just double click on it to load it back up in Maple, and you can make any changes required and just generate the custom component again. So in this example, we created this custom component, DC motor, which we use to actuate this simple pendulum here. In the next example, we're going to go and extract the differential equations of an electric circuit and then convert it to a transfer function. So we'll start a new project. And I'm just going to start with an example that's already in MapleSim. So coming down here to the Examples tab, I'm going to grab this RC circuit example. So first I'm going to prepare the model. So I'm going to group all the components apart from the input and create a subsystem. So remember, just right click and create the subsystem. So this is my RC circuit here. So if I go into there, so I'm going to grab all the components apart from the input and right click to create a subsystem. So this is my RC circuit. So if I double click on the component and go into it, so I see all those components are in there. So I can click on the boundary and just expand it. Move components around as required. So now I'm going to drag in a voltage sensor. So I'm going to go back up to the electrical library. And grab this voltage sensor here. And just rotate it. And then connect it. So I'm going to grab all the components in the subsystem apart. So I'm going to grab all the components in the design, apart from the input, and right click to create a subsystem. I'm going to call it my RC circuit. So when I double click, and go into there, we see that all the components are in there. So I can just expand the boundary here. I can move this ground down a little bit. So now I want to grab a voltage sensor from the electrical library and just drop that there. And flip it around. Then I'm going to connect it up to there. Connect the negative. To create an external port, I can just grab this and bring it to the boundary of the subsystem, so that when I return to the top level, I've got that port there. So now we're ready to go and extract the equations. So again, I'm going to click on this paperclip icon, and the attachment I want this time is equations. So I can call it my RC equations and say create the attachment. So this brings us into Maple. The first thing we're going to do is to load the subsystem. So it's my RC circuit, so this subsystem here that we just prepared, and ask Maple to load it. And then once it's loaded, we can scroll down and we can view the DAEs down here. And up here in this table, we can see the system parameters. Using this button here, we can toggle the parameters in the system to be symbolic, or you can choose to go right into the table and just edit specific parameters that you want. So for example, here I can just select a few parameters and set them to be symbolic. Change this here. So once I've done that, I'll then say reassign equations. And then we see the DAEs and the ODEs and the algebraic equations of the system are now available to us. And from here we can go on to perform different kinds of analysis using the power of Maple. So we'll return to MapleSim and look at our next example. So now we're going to simulate a model and then explore MapleSim's visualization tools. So I'm going to grab an existing example from the examples palette. I'm going to grab a multi-body example here. Okay, so we're going to use this 5 degree of freedom robot as our example. So I'm just going to start by simulating it. And then we'll go into the visualization window and see the plots and animations. So here we see the 3D view of this robot. Now you can zoom in and out, you can pan left and right, you can rotate and view the model from just about every angle. If I press play, we now see the motion of this robot. We've attached a trace probe to the arm so we can view its motion in 3 dimensions. If I press play again, we can see here in the plot this blue line follows the motion of the robot in real time. So over the period that we're viewing, we can see what the different values are doing at each specific point in time. So we can go in and look at specific plots in more detail. So here we're looking at the actual joint angles. So we can go in and look at the plots in more detail. So here we can see a comparison of the desired position against the actual position that we achieved in simulation. We can zoom in and just reset that. Using this chain button, we can link plots together. So this means that plots in this window can be linked. So any change that occurs in one plot will be propagated through the other plots within the same window. We can also create custom plots. So for example, I can look at this desired value for joint 5, for example, and click this custom plot button to add it to the plot window. So there's the desired angle of joint 5. And now I can add other plots onto here. So for example, if I want to compare it to the actual, I can just come in here and drag and drop actual value onto the plot. So the two values are now overlaid. And as before, I can zoom in and get a closer look. We can also add a second plot to this same plot window, so in this space down here. So this is done using the shift button. So for example, I can look at the actual value for joint 1 here and just click shift and press that. And we see the actual joint angle for angle 1. So now let's return to the MapleSim model. Let's go into the servo 1. So here we can see that the position of the servo motor is controlled by this feedback loop. Now, looking at this motor here, let's say we wanted to view its torque. But here we see that there's actually no probe attached. Now, MapleSim actually provides additional simulation results to those that have been explicitly specified using probes. So returning to the visualization window, instead of looking at just the probed values, I can choose to look at all the parameters in the system. So now I can go down and look for servo 1, look at the motor, and there's its torque. So I can now click on this plot here and then right click on this torque value and say add it to the secondary plot axis. So now I can overlay it onto here. Next we can look at the 3D construct window. So here we see the 3D visualization of the robot. I can anchor this to be on top. And the cool thing here is that if I click on any part of the robot here in the 3D window, it gets highlighted in the 2D view. And that works both ways. So if I click on this component here in the 2D view, it gets highlighted here in the 3D window. Another thing that we can do is to save simulation results. So let's return back to this window. So when we ran the results, it came up here as latest results. So what I can do is to save it, and I can rename it to initial results, for example. So supposing you want to make an update to your design, see what the changes give you, and then compare what you're getting to what you had before. So I'm going to save those results and then go back to my model. So back to the top level. And let's say I want to change the amplitude of the end effector oscillation here. So if I just come here and change this to 1/4, and then rerun that. So when the visualization window comes up again, we see latest results, so that's one we've just run, and then the initial results are the one that we saved just a minute ago. So here we see the results overlaid. I'm just going to zoom in to here. Now you can choose to look at just one set of results at a time or overlaid. So I've made a change and I want to see what the effect of that change is first of all. So I'm going to go and just right click, toggle visibility. So I'm going to hide the initial results. So I'm just looking at the latest results to see what effect the changes had on the system. And then you can always go back, toggle that back in, and then you can view the comparison to easily and quickly see what effect the change you've made has had on your design. And if your simulation had numerical results, this can be saved to a text file as well and exported. So these are just some of the things that we can do in MapleSim. So we've created our first model, we've created a custom component, we have extracted equations, we have also looked at the visualization windows and see what we can do in there. There's also a wealth of resources available on our website, so maplesoft.com/products MapleSim. And in there, you can find out a lot more about MapleSim, its features, look at demos and videos, and view our extensive model gallery. So this is a collection of different models for different applications that you can use as examples or references for something that you're building. So we have models across different industries. So this can serve as guidelines or examples to help you in your project. The MapleSim page also has links to user stories and any case studies that we have, as well as links to webinars and white papers related to MapleSim.